Hello everybody, hope you all are doing fine. I welcome you all on my channel mathskpreet. We were doing chapter number 8 Quadrilaterals of grade 9 from NCERT. Today you'll see the proof of the Mid Point Theorem, its converse and few examples from the same book NCERT. Okay, so let's start with the theorem. It says that the line segment joining the midpoints of two sides of a triangle ABC is the given triangle. Here E and F are the midpoints of these two sides. We have to show that this line segment which is joining these midpoints, EF is parallel to the third side BC. This is the statement of Theorem 8.8 from the book. So what is given to us? Given A is midpoint and F is midpoint. So AE is equals to BE and EF is equals to CF. This is given to us. What we have to show? We have to show that this EF is parallel to the third side BC. Okay. To perform the proof of this theorem, we have to do some construction. Construction is what? We will draw this line segment or line CM parallel to AB, and here we have to extend this line segment EF joining the midpoints of the two sides of the triangle to the point D on CM. Fine, this is the construction here. Draw CM parallel to AB and extend EF, this EF to point D. Let's see what we have to do further. So here, if I show that this ED CB or BCED is forming a parallelogram, then opposite sides of a parallelogram are parallel. Therefore, we can write EF is parallel to BC. Now, to show that this is forming a parallelogram, what we have to do? We'll consider these two triangles. This triangle EAF and DCF. Let's take these two triangles. This is my A, E, F, and this is F here, C here, this is point D. So we are taking these two triangles. Let's see which corresponding parts are congruent here in these two. In triangle AEF and triangle what? CDF. What we are having? We are having these two angles equal through vertically opposite angles. And what we have? We have AF is equals to CF. This is given to us. What else we have? We can also write that this is forming a Z. So this pair, angle A and C, will be equal through the alternate pair of angles. Let me write. So angle AFE will be equals to CFD. What is the reason? Vertically opposite angles. Please write complete. Next is what? AF is equals to CF. This is given to us. Fine. Why? Because F is the midpoint of side AC. What else? Angle EAF will be equals to DCF. How? This is alternate pair of angles. Why? Alternate pair of angles. What is the reason here? Because this CM is parallel to AB and this AC is acting as a transversal. So this is making a Z and this pair will be equal of the angles. Fine. So we have this is angle, this is an angle, side angle. Therefore we can write by angle side angle criteria. What we are having? We are having that these two triangles are congruent. Triangle AEF is congruent to triangle CDF. So when these two triangles have proved congruent, then by CPCT, what we can write? We can write that AE will be equals to CD. AE will be equals to CD. Therefore, by CPCT, we can write AE is equals to CD. So what is the use of these two sides that we have just proved equal? So this side is equals to this side we have just proved. So we can mark it number 2 and here AE is equals to BE. This is number 1. Say. So from 1 and 2, this AE is equals to CD and this AE is equals to BE. So we can write that this BE is equals to CD. So from 1 and 2, I am writing here from 1 and 2, what I am having? I am having AE, we need not to write, we can just compare the right hand side. So we can write BE is equals to CD. Fine. So BE is equals to CD. I have. Also what I can write that this BE is parallel to CD. Also this BE is parallel to CD from construction. Okay, this BCDE, this figure is what? This is having four sides, so this is a quadrilateral. Fine, we have just proved that a pair of opposite sides of this quadrilateral is parallel as well as equal. We have just proved. So we have a result from where we can write that this is forming a parallelogram. This quadrilateral is now a parallelogram. How? Because a pair of the opposite sides of this parallelogram is equal as well as parallel. So therefore BCDE is a parallelogram. So what is the property of a parallelogram? That opposite pair of sides of a parallelogram are parallel to each other. Fine. So here ED will be parallel to BC. Why? Because ED is opposite to BC. So ED is parallel to BC, but our requirement is what? EF is parallel to BC. So we can write this much part. EF is parallel to BC. So here I can write, let me erase all this. So I can write ED is parallel to BC. Therefore, also we can write EF is parallel to BC. First part we have proved here. So let's see the next part. This we have to prove now. As BCDE we have proved a parallelogram. Therefore, opposite sides of a parallelogram are also equal. They are parallel and equal to each other. Here we have used the concept of parallel, and here we are using the concept of equality. So I can write, therefore BC will be equals to the opposite side ED. Now this ED can be written as EF plus FD. Fine, EF plus FD. But we have just proved these two triangles congruent. Therefore by CPCT this EF is equals to FD. So this is my FD. I can write this FD as EF. So BC can be written as EF plus EF. How? We can write by CPCT of congruence of triangle AEF and CDF. We have what? EF is equals to FD. Fine. So this EF is equals to FD. So we can write FD as EF. So BC is equals to 2EF. But we have to show EF is equals to half of BC. So we can take this 2 down. 1 by 2 BC on the left hand side. So here I am writing as EF is equals to half of BC. This we have proved. Also we have to show that EF is equals to half of ED. So here clearly BC is equals to ED. So I can put the value of this BC as ED in this proof. So this can be written as half of ED. You can mark it number 3 and can write here from number 3. Fine. So from number 3 I have written that EF is equals to half of ED. So this I proved this part as well. So from the midpoint theorem we are getting this EF is parallel to BC and EF is half of BC. Fine. So this is the proof. Hope you understood. Let's see the statement and the proof for its converse. So this is the statement for the converse of the midpoint theorem, theorem number 8.9. It is saying that the line drawn through the midpoint of the one side of the triangle and parallel to the another side, parallel to BC, bisects the third side. So this given E is midpoint of AB, this EF is parallel to BC, and we have to show that F is the midpoint of AC. So we have given as AE is equals to BE. This is given to us. What else? EF is parallel to BC is also given. Fine. To prove that AF is equals to CF, or F is midpoint of AC. Fine. Both means the same. So here construction is the same as we have done in midpoint theorem. Draw CM parallel to AB, extending EF to intersect CM at D. Fine. This is the construction here. We have ED is parallel to BC. This thing we have. And what else we have? This EB is parallel to CD. Also EB is parallel to CD. This is through construction. This is given to us. Fine. So this pair is parallel and this pair is parallel. Therefore, what we are having, BCDE is a parallelogram. Why? Because both the pairs of opposite sides are here parallel, therefore this is forming a parallelogram. So when this is forming a parallelogram, I can write that EB or BE is equals to CD. Therefore BE is equals to CD. Why? Because opposite sides of a parallelogram are equal. We have a result, okay, equal to each other. This is the reason. Now BE is equals to CD we have just proved. What we are having? We are having that AE is equals to BE. Mark it number 1 and mark this number 2. Now from 1 and 2, BE is equals to CD, BE is equals to AE. So I can equate AE and CD. AE is equals to CD. AE is equals to CD. I just have proved. Fine. Now in these two triangles, I am talking now in triangle AEF and triangle CDF. What we have just proved, AE is equals to CD. What else? We can write that angle EAF. EAF will be equals to DCF. DCF. This angle will be equals to this. How? Pair of alternate angles. Pair of alternate angles. Why? Because we through construction we are having AB parallel to CD and this AC is acting as a transversal. Therefore this is a pair of alternate angles. Also what we have these are two parallel lines and this ED is acting as a transversal. So I can make this angle equals to this angle again through alternate pair of angles. So I can write this angle is equals to this angle. Fine. I am writing angle AEF is equals to CDF. This angle is equals to this. This angle is equals to this. I have written. Okay. So this is also with the same reason, all pair of alternate angles. I have just proved that this angle is equals to this. This angle is equals to this angle, and AE is equals to CD. Here, therefore, by angle side angle rule, what we have proved these two triangles congruent. Fine. What we have to actually prove, we have to prove that AF is equals to CF. Therefore by simplicity I can write AF is equals to CF. Therefore triangle AEF is congruent to triangle CDF. Therefore by simplicity AF is equals to CF. Fine. So this is saying that F is midpoint of side AC of triangle ABC. Hence proved. This is example number 6. This figure is given to us. Triangle ABC is given to us. DEF are the midpoints of side AB, BC and CA respectively. And after joining these midpoints, we have to show that this triangle is now having 4 congruent triangles in it. This complete triangle ABC is divided into 4 congruent triangles. We have to prove. So let's see how to prove this. As DEF are midpoints of AB, BC and CA respectively. This thing we have. Okay. So if D and F are midpoints, and on joining these midpoints through the midpoint result of the midpoint theorem, what we are having, we will have that this DF is parallel to BC. Therefore by result of the midpoint theorem, we have what we have DF is parallel to opposite side BC. What else? After DF, DE. DE is parallel to AC. What else? This EF. EF is parallel to this EF is parallel to AB. This is now we have from the result of the midpoint theorem. Now we have to show that this triangle is divided, this complete triangle is divided into 4 congruent triangles. Basically first we can say that this triangle is having three parallelograms. First parallelogram is this. We can write that. Now we have three parallelograms. Okay, what are these? First one is BEFD. Okay, second parallelogram is this. We can write it as DECF. DECF. Third is this. ADEF. ADEF. In this figure, through the joining of the midpoints of all the three sides of this triangle, we are having what? Three parallelograms. Each parallelogram is having this figure in it. First is this. Let me draw. First parallelogram is DFBE. Second is, this is the name, DECF. DECF. Which one is the third parallelogram? ADEF. 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 So these are three parallelograms we are having in this figure. Okay. So what is the diagonal here? DE. What is the diagonal in the next? EF. And what is the diagonal here? DF. This is the diagonal according to the figure. So we have a result that diagonal of a parallelogram divides it into two congruent triangles. In the very beginning of this chapter, we have studied the proof of this result that diagonal of a parallelogram divides into two congruent triangles. So we can write with the diagonals. We are having these parallelograms with the diagonals. What are the name of diagonals? DE, comma EF and DF respectively. Therefore, triangle, which triangle? From the first figure here, I can write triangle BED is congruent to triangle, second triangle, EFD. EFD. So also triangle in the next figure. In every figure we are having EFD triangle. EFD. So the first is CEF. CEF is congruent to EFD. In the third figure, in this figure again, EFD we are having. So we can write it here. And what is the other one? AED. AED. So we are writing this through the result. Here you have to write the complete result that a diagonal of a parallelogram divides it into two congruent triangles. So all the four are congruent to each other. Why? Because this is congruent to this, this is congruent to this, this is congruent to this. Means all the three are congruent to the single triangle. Therefore, these three will be congruent to each other as well. Therefore, we can write, therefore, all the four triangles. What are the name of these triangles? Triangle BED, triangle CEF, triangle AED, and the last one is, which is common in all, EFD. EFD. All the four triangles are congruent to each other. This was what we have. So this is the given figure for example number 7 given in the book. Here what is given to us? L, M, N. These are three parallel lines here, and P and Q are two transversal intersecting L, M and N such that this AB is equals to BC. These are two intercepts on these lines by this transversal, and these are equal. AB is equals to BC is given to us, and we have to show that this transversal Q is making equal intercepts on L, M, N. That means we have to show that DE is equals to AF. Let's write what we have. Given L parallel to M parallel to N, what else we have? We have AB is equals to CB. Mark it number 1. We'll make use of it. To prove, we have to show that DE is equals to FE. This thing we have to show. So in this question, let us join this AF to prove the result. So here we'll write, let us join AF such that its intersecting line M at point G. Two lines are given parallel to us, and this from the figure is very clear that this AC is non-parallel to DF. When a pair of opposite sides is parallel and second pair is non-parallel, then we have a trapezium. So this is making a trapezium ADF, and by joining this AF we are getting these two triangles out of this complete trapezium. So we can write, we have triangle ACF and triangle AFD in trapezium. What is the name of trapezium? ADFC. Fine. So first we will take the first triangle. In triangle ACF, what we have that this BG is parallel to CF. BG is parallel to CF. Why? Because M is parallel to N. And what else we have? This number 1. Also we can write it again. AB is equals to CB. Then this G will be the midpoint of the third side from the result of the converse of the midpoint theorem. Okay. Therefore, by converse of the midpoint theorem, what we can write? We can write G is midpoint of side. Which side? AF. Okay. G is midpoint of side AF. That means, that is, we can write AG is equals to FG. Fine. Mark it number 2. So when AG is equals to FG, we have proved, then we will shift to the next triangle. Now again in this triangle, triangle ADF. In this triangle, G is midpoint of one side such that the line segment from that midpoint is parallel to AD. This is given to us. Therefore, again by the result of the converse of the midpoint theorem, what we will have? This E as the midpoint of DF. Similarly, we can write here in second triangle. Fine. Here I am writing in triangle which AFD. This triangle. What we have? We have just proved from number 2. From number 2, G is midpoint of this from number 2, and we will write from number 2 comma also M is parallel to L, that is GE is parallel to AD. Therefore again you will write it like this complete reason. Therefore by converse of the midpoint theorem, what we will have? We will have E is midpoint of side DF. So when E is midpoint of side DF, we will reach to the result that DE is equals to FE. This was the thing that we have to prove, and we have proved this thing by using the result of the converse of the midpoint theorem. Very easy question it was. So this was the proof for example number 7. I hope you understood. In this video we have seen the proof for the midpoint theorem once again on the board, and its converse example number 6 and 7. I hope you understood. In the next video we will see the next exercise 8.2 in detail. Till then, take care, study hard, hit like if you like, subscribe for more, and thank you for watching. Have a good day.